Hi, I'm Tyler Zawacki. I'm here in David Braun and Allison Brooks's Stone Age Archaeology Lab here at George Washington University, and I'm going to be walking you through the process of Reflectance Transformation Imaging. In my experience, this method has been used for lithic artifacts, but it can also be applied to a wide range of artifacts or fossils in terms of looking at the more detailed surface level morphometrics of an object. So over here to my right, we have the basic setup for what you're going to be using for this method. First, you have the camera set up here on anything that you can use to hold the camera like this, facing directly downwards onto a tray with the artifact in the middle, as well as these two reflective spheres on the side of it. And on the tray is important that there are 12 marked, evenly spaced spots around it for different points that images or that the light is going to be placed at later in the process. So now I'm going to show you an example of the method in the process of being used on an artifact. It is very important that this method is used in a dark room. As you can see here, this is not a completely dark room, but ideally this will be done in a completely dark space because, as you will see, these reflective spheres here are used later in the process to determine where the angle of the light is coming from. So it is very important that the program that is used to make the RTI models recognizes that in the spheres, which can be altered by other light sources coming in. So to start the process here, you're going to want to take a measurement of your artifact. This one happens to be about 5 centimeters. And then you want the light source to be approximately 4 times that diameter of the artifact away. So in this case, we have the light source here is going to be 20 centimeters away. So right about here is where we're going to want the light source. And then at each of these points along the circle on the tray, we are going to want to take 4 photos of the artifact at 4 different angles, those being 5 degrees, 15 degrees, 40 degrees, and 65 degrees. So we'll do an example. First photo here would be at 5 degrees from the artifact. So you're going to want to measure the angle at 5 degrees on the protractor and from the artifact here. That is going to put the light approximately there. So then we would take a photo. The light would then move to the next point here at the same angle, at the same distance. We would recheck the distance and the angle on the light. You'd move in a full circle, 360 degrees around the artifact, and then move on to the next angle, and eventually take 48 photos of each artifact. And here you can see what each lighting angle would look like for one point around the artifact. The first being, again, 5 degrees, and then 15, and then 40, and finally 65 degrees. And this is, again, going to be repeated 12 times as the light circles around the artifact to take one photo at each lighting angle. Okay, so after you've collected all of the photos, you can then put all the photos into this program called Relight Lab. And what you do in Relight Lab is you go in and you identify the spheres in the photo, and then within the spheres, the program automatically identifies what it calls highlights, which is these points here, where the sphere captures a reflection of the light source. So then it can recognize the distance and the angle that the light source was when the photo was taken. So it does the same thing for all 48 photographs, which you don't need the full 48 photographs, but that's the process that we followed from Luton et al. And it makes a composite RTI file for you. And then the final step in the process is moving your RTI file into another program called RTI Viewer. And in this program, first your base RTI model is populated that can be seen here, which has a lot more detail in terms of surface level details that can't be seen with the naked eye. And within this, you can change the light settings up here at the top to see how different lighting angles might look. You can move between different modes. This is a different light enhancement mode and a third different mode. For analyses, in this case, we might be looking at flake scars, but this type of analysis can be done on any type of artifact or object that you're looking for surface level details and markings. Thank you so much for watching, and I hope that you have learned a little something about reflective transformation imaging.